This tutorial looks at bearings and navigation. So by the end of this, you should be able to interpret bearings and navigational problems and hence make calculations involving both of these. All right, so true bearings. There's actually two kinds of bearings we're going to look at. There's true bearings and there's compass bearings. True bearings is also called a three-figure bearing, and it's measured clockwise from north to the required direction, and it must be written as three numbers followed by degrees true, so degrees T. Some examples. This first one, we're looking at having to go from north all the way around to the angle. So I know this is 60 degrees. I know that in a circle there's 360 degrees, so I can do this as 360 minus 60, so my answer is 300 degrees true. I can do something similar for the next one. I note that I've got 270 degrees, and I'm going to add that little 40 to it, so 270 plus 40 is 310 degrees, and that's my answer, 310 degrees true. Two more examples. This first one, I've got 90 degrees, and then I've got this little portion, which is 90 minus 35. So 90 plus 55 is equal to 145 degrees true, which is my bearing for that question. And the last one, 180 plus 30 is going to give me 210 degrees true. Compass bearings. Compass bearings is more traditional. This is what you've probably heard more of. So a compass bearing is an angle measured from the north-south direction in either the east or the west direction. So it's written as north-south, the degrees from north-south that you are, and then east-west as are you going east or west. So that might look a bit confusing, but basically you're looking, are you closer to north or to south? So I'm closer to north and I'm in a westward direction. And how far from north am I? I'm 60 degrees. So this would be written as north 60 degrees west. That is my compass bearing for that question. So note the angle always comes from the north-south line. So for the next question, where again I'm looking at northwest, I'm not looking at 40 degrees, I'm looking at 90 minus 40 degrees. So 50 degrees from the north line. So north 50 degrees west. Next example, I'm no longer looking north, I'm more southward, so south, and I'm also heading towards the east direction, so southeast, and I'm 35 degrees from that north-south line. So 35 is my degree. So south 35 degrees, east. My next question, I am southward and I'm heading towards west. I need to know how far from the line I am. I am 30 degrees from the line. So this is going to be south 30 degrees west. Now the difference between navigation and bearings. Bearings deals with direction only, whereas navigation deals with both direction and also distance. So navigation is where we get more of our trigonometry questions. So example here, the group of bushwalkers leaves point P, which is down here, and walks or runs north-south to the point Q, which is 30 kilometers away. To do that, they go on a bearing of 20 degrees and they reach Q. What's the shortest distance from X, distance X from Q back to the road correct to one decimal place? This is a right angle triangle where you can label your sides appropriately. So my angle is down here, opposite, hypotenuse, adjacent. I'm going to use sine, so sine theta equals opposite of hypotenuse. Substituting in my values, so sine of 20 is equal to x over 30, where x is equal to 30 times sine 20. Using my calculator, make sure you're in the right units, so I'm in degrees, that's good. 30 times sine 20 gives me 10.36, 36. except, no, 26, but I want one decimal place, so 10.3 kilometers. My units is important. Please make sure you put that in. Okay. Looking from the point Q, what would be the three-figure bearing from their starting, or of their starting point? So there's a few ways to do this, but in all of them, I would draw in a fake north line. So note this north line that's going in from this point. That's really important because what you should know about a three-figure bearing or a true bearing is that it has to come from that north line. So I'm interested in that angle. I'm going to redraw that diagram. So I've redrawn it down here and I've put in some triangles. Just because I know how to deal with the triangles pretty easily, and I can put in some measurements, so 20 degrees, 90 degrees, and I can also calculate that last one. So theta is going to be 180 minus 90 minus 20, which is 70 degrees. I can now calculate alpha by doing 270, which is 3/4 of the circle, minus theta, so 70, which will give us a result of 200 degrees. True. Now, the other way to calculate that is to use the parallel lines. So this here is parallel to this here, which means that this angle must be the same as this angle, which means that this in here has to be 20 degrees. So 180 plus 20 is 200. So that's two ways to calculate your true bearing for that